We have spent about a week multiplying polynomials. We started with just distributive property, multiplying by a monomial. We worked into things like FOIL and special products and even binomials times trinomials and things like that. But we've spent several days on multiplication. Now we're going to spend several days on unmultiplying, or the mathematical term for that is factoring. Okay? We're going to learn several ways of factoring. And we'll do one a day, do some practice, make sure we got it. But this is a big deal. This shows up in other areas in other ways. This is a process you learn that you'll see the structure later. Okay? So today we are going to factor polynomials using a GCF. Okay, now let's review GCF. Let's come down here and review GCF. First of all, what does GCF stand for? What does it stand for? It stands for the greatest common factor. Okay, now when we're talking about numbers, the GCF is the biggest number that divides or goes into evenly two or more other numbers. Okay? So what we're going to do, first of all, we're going to review how we did this with numbers. If I've got 12 and 28, now you can very quickly find the GCF without any work of 12 and 28. What's the biggest number that goes into both 12 and 28? I'm going to review with you the upside down division, the ladder method, okay? You might remember that you would write these two numbers side by side and you'd say, what goes into 12 and 28? Oh, I know, 2 does. And then you would divide. 2 goes into 12 6 times, 2 goes into 28, 14. Then you would ask yourself again, does anything go into 6 and 14? Well, I think 2 does. 2 goes into 6 3 times, 2 goes into 14 7 times. And then you would get the GCF from over here on the right. And I just saw a teacher that I follow and read some of her blogs and things. She draws a big G over here. So here the GCF is 2 times 2, which is 4. Okay, now you knew that without doing the ladder, but that's just to review the upside down division for you. Okay, so what about 18 and 42? What do we know that goes into 18 and 42? Well, I think 3 does. 3 goes into 18 6 times. 3 goes into 42. Make sure I do this right. 14 times. Well, there's 6 and 14 again. 2 goes into 6 3 times. 2 goes into 14 7 times. This over here is the GCF. The GCF would be 3 times 2, which is 6. Okay? So you've done that. You have found the GCF of numbers, maybe using the upside down division. Now let's see what that looks like with polynomials. Now, let's look at these expressions. These aren't numbers. These are polynomials, okay? But it's going to be the same idea. Let's look at 15m squared minus 9. So you're going to write that, and you're going to do the upside down division like we did. But now we've got to think about numbers and variables, okay? So first look at 15 and 9. What goes into 15 and 9? Or does anything go into 15 and 9? Well, we know 3 does, okay? Now we're going to divide. 3 goes into 15m squared, 5m squared times, okay? Just to show you, if you did 15m squared over 3, that 3 goes into the 15 5 times, you're left with 5m squared, right? Okay, 3 goes into minus 9, minus 3 times. Now, check this. Does anything go into 5 and 3 besides 1? No. is the m common to both? Like, could we divide both of these by m? Could we take an m out of both of these? No. So we're done, okay? So this over here is the GCF. And what you do for your answer, when you factor, and what I should have said when we started that I forgot, that factor means to write as a product. Okay? So what you do is you take your GCF, 3, and you put the 5m squared minus 3 in parentheses. And we just wrote 15m squared minus 9 as 3 times the quantity 5m squared minus 3. Now, when you factor out a GCF, this is like undistributing. We are reversing the distributive property. What would happen if we distributed right now? 3 times 5m squared is 15m squared. 3 times negative 3 would be a minus 9. So you can check every factoring problem by remultiplying. But this right here is the factored form because it is written as a product, something times something. Okay? All right, now let's look at 5x squared plus 10x and let's write it as a product. So we're going to do the same thing. I'm going to write my 5x squared plus 10x and I'm going to do my upside down division. What goes into 5 and 10? 5 does. So 5 into 5, that cancels. 5 into 5, that cancels. You're left with x squared. Plus 5 into 10 goes 2 times, and the x is still there. Okay? So I took out the 5, and I'm left with x squared plus 2x. Well, now notice, I have an x squared and an x. That's common, right? And we're looking for the greatest common factor. So what can I take out? What is common to both of these? How many x's is common to both? Well, this has a single x, and this has x squared. So the only thing I can take out is the smallest exponent. So we're going to divide here by x. So make yourself a note that with variables, you want to factor the smallest exponent. Okay, that's important. All right, now we're going to divide x into x squared. Now what we're looking at here, this is sort of scratch work, but x squared divided by x. Remember when we learned our exponent rules, when you're dividing powers with the same base, what do? You subtract your exponents. Okay, so I'm left with x. X squared divided by x is x. Now, what happens with 2x divided by x? Well, if I come over here and I show some scratch work, 2x over x, those x's cancel, right? When I take an x out of 2x, I'm left with 2, okay? Now, is there anything common to x and 2? Anything else I can factor out? No. So, this over here is my GCF, so 5 times x is 5x, and I'm left with this down here at the bottom, x plus 2. And yes, you have to rewrite this, okay? You have to rewrite it as a product. You have to rewrite it as a monomial times something in parentheses, okay? We undistributed. We took out the 5x. What would happen if we remultiplied? 5x times x is 5x squared. 5x times 2 is 10x. You can recheck them all, okay? All right, now let's work through this one. I'll try to do this one a little quicker. I'm going to let you do some in a few minutes. So I have 21a cubed minus 14a squared. So what goes into 21 and 14? 7. 7 into 21 goes 3 times. The a cubed comes down. 7 goes into 14 2 times. The a squared comes down. Now look at my variables. A cubed and a squared. Are there a's in common? There are. What's the smallest exponent? A squared. I can't take 3 a's when there's only 2 there. So I'm going to take a squared out. Okay. Now, a squared into 3a cubed. The 3 is just going to tag along. What happens when I divide a cubed by a squared? I subtract my exponents, 3 minus 2, and I get a. Okay? Now, a squared into a negative 2a squared. Well, the negative 2 is going to tag along. What happens with a squared divided by a squared? They cancel, right? Took it out, it's gone. So, my GCF, I'm left with 7a squared. My parentheses down here, I'm left with 3a minus 2. So my answer is 7a squared times 3a minus 2. If we were to remultiply, we'd get what we started with, okay? But we want to write it as a product, so our answer is this multiplication. Okay, you try this next one. Pause the video, you try it. Okay, I got 4 times the quantity, 4x minus 3y plus 6. Notice there weren't any variables that were common to all three terms, so all I had to take out was the 4. All right, I'm going to try to get through this page pretty quick since I talked so long on that last slide. I want you to try these first two by yourself. They're just like what we were just doing. You try those, then check them. For the first one, I got 6x times the quantity 3x squared minus x plus 4. And the second one, I got 4a squared. Notice the smallest exponent was 2, so I got to take out a squared. Also here you can see pretty easily the subtraction. 5 minus 2 gives you the exponent of 3. 3 minus 2 gives you the exponent of 1. And the a squareds cancel. Times the quantity 7a cubed minus 3a plus 5. Okay? Now, what happens when there's more than one variable? Well, exactly the same thing. So, let me do this one with you. 3a squared b squared plus 18ab. When I look at my numbers, 3 goes into 3 and 18. I'm left with a squared b squared plus 6ab. Then let's look at my a's. I can take out what? What's my smallest exponent? A. Let me get back to my pen here. Now, a into a squared b squared. I'm left with an a. I haven't done anything with b squared yet. My 6 is stuck. These two a's, a into a, that cancels, and I'm left with 6b. Okay? Now I look and I see I've got this b in common. Okay? So I can also factor out a b because my smallest exponent is 1. Here, the a is stuck. B squared divided by b. I'm left with b. Here, the 6 is still stuck. And these two b's cancel. Okay? So now my GCF is right here. That's a 3ab. And then in parentheses, I'm left with ab plus 6. Remember, you can always check this. 3ab times ab is 3a squared b squared. 3ab times 6 is 18ab. Okay? So you use what we just did there, and you try it on this one that has x's and y's and z's. Okay, for this one, I get 5x squared yz times 3xy minus 4z. Notice I have to stop. I stop here because nothing else is common to both terms. I have a z, but it's not in both terms. I have an x, it's only in this term. I have a y, it's only in this term. You cannot factor something to the side unless it's common to every term. Now, let me also point out, this upside down division is a tool. As you get more practice and you see what's going on, you won't maybe not have to do this upside down division. You might be able to just look at it and take out what's in common. You can also start combining some of the numbers and variables, but it's a tool to get you started till you're comfortable with it, and then you can start leaving off some of that. Okay? We will practice with this tomorrow. I know it's new, I know it's weird looking, but you're going to get really good at it. See you in class.